Hello, let's continue for the specifications that you have covered me, sorry, that you have sent me in the pictures, and we have to discuss. So for the first one, we have the termination panel, 400 ampere rated coppers and current transformers. That is given for 100, 400, 200, 150 to 1 milliampere. And we have the voltage transformers, uh, 13,800 to 110 and 13 VA with primary and secondary fuse protection. And we also have to set live line indicators, anti-conditioning heater circuits, and Castle lock with key code, designation and warning labels identical to the Falkirk panel content contract. The number is written that you have talked about in the picture, and this is for the equipment specifications that are mentioned for the second part. The remaining are the same. The quantity required is 1, and for the insulation is using we is vacuum here, and the location is indoor, and voltage level is 13.18 kilowatt, and for the protection we are using overcurrent and earth, and the fault rating is 25 kiloampere maximums with 3-second time period, and the current rating is 630 ampere. And if we talk about further about the overcurrent and earth fault protection and motor protection, circuit connected using the bus bar, and the cross line lamp color is red, and the tripped lamp amber, panel heater circuit with earth facility available. So if we discuss that what we require to design these systems, we will need to consider these steps for the system designs, that we have to require a CT, VT, PT, and HV breaker with the PLC systems. So if we move on the first step, that why we need to use the CT, they are used to basically step down current to a measurable level for the metering and protection. So we have CTs with various ratios that is given in the diagram. For the VT, we already also discussed, they are used to step down the voltage to measurable level for the metering and protection system. So we have VTs with a ratio of 13,800 to ratio 1:10. And for the PT, it's also another term for a voltage transformer. So we will consider this as a part of the VT specifications. And for the metering panels, these panels houses the CTs, VTs, live line indicators, anti-condensation heater circuits, and Castle lock designation and warning labels. For the Castle lock, we already discussed in the electrical drawings training. And for the HV breakers, the Schneider Jenny Evo, this is the model of the breakers with a voltage level of 13.8 kilovolt, and the fault rating of the HV breaker is 25 kiloampere within the 3 second, and current rating is 630 ampere. So it has also various protection mechanisms in the HV breakers, and ancillary components like lamps, panels, heaters, alarm, and circuit earth facility, etc. And if we talk about the PLC systems, basically PLC system controls all the other components like CTs, VTs, and the HV breakers remotely, and it also display the information that it basically, and it is integrating all the components together. It's receive data and send data from the CTs and VTs to control the whole circuit. So based on these components, we need to design a system architecture that includes must be wiring diagrams for connecting the CTs and VTs to the metering panels, and communication protocols between the metering panel and the PLC systems, and control logic for remotely operating the HV breaker, and we need a user interface design for monitoring the status of the HV breaker and other relevant parameters. And we have to also make sure about the safety measures and fail safes to ensure proper operation of the systems. And for the wiring diagrams, the CTs and VTs will be connected to the metering panel directly, and each CT and VT will have its own set of wires for primary and secondary connections, and the wiring should follow safety standards and regulations, ensuring proper you can say insulation and grounding, that is must be done. The metering panel should have terminal blocks or connectors for easy and secure connection of the CTs and VTs. And for the communication protocols, uh, we the metric panels communicate using the PLC system with the suitable communication protocols such as Modbus and Ethernet, etc. And for the PLC systems, the PLC system will receive data from the metric panels. you can say regarding the current and voltage measurement, as well as the other status of the information also from the HV breaker. And communication will be bidirectional, allowing the PLC system to send commands to metering panel for remote operation of the HV breaker. And for the control logic of HV breakers, the PLC system will implement control logic, obviously, and the logic will include safety checks and interlocks to prevent unauthorized or unsafe operation of the HV breaker. So it also we also incorporate fault detection and response mechanism to ensure reliable operation of the breaker. And for the user interface design, it's represent a graphical representation of the HV breaker and other relevant parameters. And it's also at the same time display the real-time status information for the breaker positions, like it's open or closed at that times, and the measurements of the current and voltages, alarms and trips events like that. And user can be able to remotely control the HV breaker through that interface with appropriate access control and authentication mechanism. And for that we have to ensure these safety measures and fail safes. System will include an emergency stop button, circuitry protection devices, and isolation devices to ensure safe operations, and also the automatically operated breakers. And fail safes will be implemented to automatically shut down the system or activate protective measures in case of abnormal conditions or failures, or any case of you can say fault. And for the redundancy, and the backup systems may be employed to minimize the risk of the system failures and ensure continuity of operation. And overall system architecture will be that citizenity will be wired to the metering panel, which will communicate with the PLC system using a suitable protocol. And the PLC system will implement control logic for remote operation of the HV breaker and provide a user interface for monitoring and control. And safety measures and fail safes will be integrated into the system to ensure safe and reliable operation under all conditions. And thank you so much. Now I hope the training is end. If you have any further queries and questions, you can please ask me in the chat. I would be happy to assist you. Thank you.